Hello, I'm Angel Tan, and I am from PG14. This is my PLC mini project, and the title name is WashDryMachine. Firstly, I've created a scaling for analog input, which is named AI, and I've used function block, as you can see from here, to create a formula to create an output. Firstly, for my formula, I'll use the maximum value, subtract with the minimum value, and subsequently, I will multiply the answer with the sensor in. And afterwards, I will use the answer from here. I would divide with 32767, and with the answer here, I would add with the minimum value, thus allowing me to obtain an engineering value out. Next, for my scaling for analog output AO, I've also used a function block, and I've also used a formula to generate out a formula to allow me to obtain a certain results. Firstly, I will use the engineering value and subtract with the minimum value. With the answer over here, I will multiply it with 32767 and obtain an answer here. Let's name it A1. Afterwards, down at the bottom, I will use the maximum value. I will subtract it with the minimum value and obtain an answer A2. Hence, I will use A1 divide by A2 to obtain the answer A. And I will convert A from real to integer, hence obtaining a skewed analog output value. Okay, now let me bring you to my GVL. For my GVL, as you can see from the above, I have my digital input devices as labeled here. I have my start button, emergency stop button, pause button, and auto stop button. Whereas for my output devices, which is under digital, I have my dryer valve 1, dryer valve 2, green LED, amber LED, rinse valve 2, rinse valve 3, softener valve, and detergent valve. For my input devices under analog, I have my temperature sensor and weight sensor. For my output devices under analog, I have my motor and dryer. For my digital, I've all set as boolean, whereas for my analog, I've all set them as integer, as you can see from the table above here. Next, I'll be bringing you to my program. I'll first show you all my table here, what I have set and what I have used. You can take a scan. I'll pause the video to have a clearer look at it. Now I'll move on to my program flow. This is my ladder diagram. For my first one that I have set is I have set up a temperature sensor, which I name it, and I have made use of the scaling for AI block, which I've created earlier here. For my maximum value, I set as 100, minimum as 0, and my sensor would be using the temperature sensor. And the engineering value, I will name it as temperature reading. For the next block, I have named it weight sensor, and I've also made use of the scaling for AI. My maximum value is 100, minimum value is 0. My sensor that I'll be using is the weight sensor, and my engineering value I will name it as the weight reading. For the third line, I have used scaling for AO, analog output. I name it as dryer control. For my engineering value, it will be for the dryer speed. The minimum value is 0, maximum value is 100, and the skewed AO value I've named is used for the dryer motor. Whereas for the fourth line, I've used scaling for analog output AO, and I've named it motor control. My engineering value will be my motor speed, my minimum value will be 0, maximum value will be 100, and my skewed another output value will be used for the motor, as this is motor control, whereas on top one is dryer control. So here is how my process will start. First, start button will be activated, and it will run straight through until it reaches wait conditioning. The moment it reaches wait conditioning, it will go through another program which I will show you at the bottom. And afterwards, once it hit a certain criteria, process will be started. And when the process started, it will start flowing all the way simultaneous. This is my wait conditioning criteria. As you can see here, once the start button is being activated, it will go through either condition 3, 1, or 2, depending on what is the condition, and thus activating the wait conditioning. What is 3, 1, and 2? Here, as you can see here at line 29, when the weight reading is less than 20 kg, the speed of the motor will be 0. As you can, and then thus activating condition 1, weight conditioning 1. At line 30, as you can see, when weight reading is more than or equal to 20, but less than and equal to 50, it will activate weight condition 2. On top is 1, here is 2. And at weight condition 2, the motor speed will be 100%. It will run at 100%. At line 31, as you can see, when the weight reading is more than 50, the motor speed would then run at 75%, thus activating wait condition 3. As you can see here. So let's hit back up. Yes. So now let's go back to line 6. These are all the timers that I'll be used for the next program or process of how the wash dry machine works. As you can see, this is a 5-second timer, and this is when rinse valve 1 is off. It will only be activated when the 5 seconds timer is on, as you can see here. And when the rinse valve 1 is off, over here the normally closed rinse 1 off will be open, thus stopping this, so it won't keep running. This is my 10-second, and 10-second one is for the detergent to run, and this is for my detergent off. You can see it's the same as the top. And this is 15 seconds for the softener, and this is for softener off. You can see here are all the timing that how long it will run. This 30 seconds is for the dryer, and this is when dryer off, the duration. This is when rinse valve 2 is on, 5 on, and this is for rinse valve 2 off. This is rinse valve 3 on and rinse valve 3 off. Okay, let's start here. Line 19. When the process started, rinse valve 1 would be activated. And thus, it will go to line 20. It will run through straight. Rinse valve would close. 5 seconds would run the timing, and then close. And it will run through rinse valve 1 and activate detergent. After activating the detergent, rinse detergent would activate. 10 seconds activated, and will run straight through until rinse valve 2. However, when the timing is up here, this will be open. This open up to stop the flow. And this will open up too. Will run, close, run. Yes, the process is roughly like this. Later I'll show you a demo on how it runs. And when reach here, when auto stop is activated, you will see the criteria of DC1 or DC2 and activate the dryer. If DC1 and DC2 is not met, then it will activate DC3. and then it will activate dryer 2. So it depends whether dryer 1 or dryer 2 on depend on the condition. If let's say dryer 1 is activated, it will on for 30 seconds and then it will off, and it will off for 30 seconds, and then the green LED, and then the green LED will be on to indicate that okay, it's done. And then after your dryer will off. Whereas for dryer valve 2, the moment dryer valve 2 is activated, it will go straight to amber light and amber LED will be on. Because when dryer valve 2 is activated, the speed is 0, which means that the dryer is not working. Or yeah. So let me bring you to the condition here. Okay, this last 3 box. When temperature reading is less than 25, dryer speed is 100. This is for DC 1. When temperature reading is more than equal to 25 and less than equal to 30, DC 2 will be activated and the dryer speed will be 50. However, when temperature reading is more than 30, dryer speed is 0 and this is DC 3. Okay, let me now show you a demo on how it's being run. Okay. So first, I will activate this, as you can see. Now it's temperature reading 0, weight reading 0. So I will change the reading to okay, you can see it changes. It's being activated. Timer running. As you can see, it's already starting to activate. You can see. Now it hits weight conditioning 2, the criteria. As you can see, it started running. And it hit dryer condition 1. You can see. So dryer valve 1 will be activated instead. You can see it's activated. And when dryer valve 1 is activated, it needs 30 seconds. Will be on for 30 seconds and we off. As you can see. And these are all the conditioning. You can see here. Yeah. So let's say if I change the temperature to higher, even higher, as you can see. Let's see. I change it to 30.5. And then I change the weight. And I change the weight to be less than 20. As you can see. As you can see how it runs. Yep. So that's all. Thank you. Oh wait, before I end, this is my under my main program. I will key in this. I'll key in this, as I wanted this to run. Thank you.